will start to look at the various phenomena that occurs inside the discharge tube when we fill the discharge tube with certain gas, and then slow by slow we start to reduce the pressure and try to study as to what happens inside the discharge tube. So as I told you, the discharge tube is a tube with two plates, cathode and anode, and there are maybe a way out through which the gas can be taken out to lower the pressure, and there is a pump filled there, right? So suppose we have filled it with air, and then when we start to study about the discharge tube and start to lower the pressure, at the beginning at the normal temperature pressure, atmospheric temperature pressure, the whole tube is filled with dark space. There is absolutely no color or there is no radiation. It's just a dark tube. So then this tube is, or this kind of thing where we cannot see any discharge or we cannot see any kind of light or glow or anything, we call this as dark discharge, because there are no glows, there are no radiation being seen. So that happens at normal atmospheric pressure. Now slowly we try to reduce the pressure, and at around 8 millimeter to 20 millimeter mercury column pressure, what happens is, from cathode to anode and anode to cathode, there is a violet color glow which moves like kind of serpentine way, kind of snake, how snakes move. So this glow starts to move from these two plates, cathode and anode, and this violet color light appears when we have the tube filled with air, or and this glow, or this violet color glow, we call as suddenly we see them first as a violet color. You can see such things when there is spark going on in a electrostatic tube. There are violet color sparks moving in a serpentine way. So between two cathodes and anodes, this glowy violet color glow that starts to move. Now if we still reduce the pressure around 3 millimeter to 8 millimeter mercury column pressure, what happens is a bright pink between these two. There is a bright pink glow that goes on, right? And in the case of air, it is bright pink. In the case of neon, if you fill it with neon, then you will see it in red color. If it is a helium gas, then we will see this glow as yellow color, and this is what we call it as positive column, right? So this column is called positive column, and you might have seen in advertisement in the shops where we see the advertisements or the signboards that comes in the advertisement of the shop. We see various colors coming in, especially this is this positive column that we see inside those signboards. So generally what happens inside those tube, the gases, particular gases are filled, and when we switch on the light, there are between these two plates there are this glow coming in, which we use in the signboard of such color. So that is nothing but this positive column. Now let's see what happens if we still reduce the pressure. If we reduce it around 2 millimeter, then what happens? This positive glow around 2 millimeter of mercury column, this positive glow starts to leave the cathode and move towards anode. And what happened in this place, there is a dark area. So this is the positive column, and this place taken up by a dark area, and we call it as Faraday dark space, right? So this interesting phenomena keeps on going on when we keep on reducing the pressure of this particular gas or the air. Now if you still remove, if you still reduce the pressure, what happens? This Faraday space still takes more area here. So there are this positive column here, then you have Faraday dark space, and from here a blue glow starts to come out. There is a blue glow. This is what is called the negative column. This is this area, there is no glow. We call this as Faraday dark space, and this is the positive column, right? Still, if we further reduce, the Faraday dark space takes up majority of this area between the two plates, and what we see is around 0.1 millimeter of mercury column. What happens is this glow or this negative column that we are seeing, this negative column leaves the cathode. So there is a negative column here, there is the Faraday dark space here, and then this positive column, it starts to appear like disc, few disc. In between those colorful discs, in between there are dark spaces. So this what we kind of call the kind of spectrum glow. This we call it as spectrum glow, and here we have kind of Faraday dark space. Then this is the negative column which starts to leave the cathode, and therefore here starts to as this glow leaves the column, this place becomes dark, and this place we call it as Crookes dark space. Now in Crookes dark space, this place is dark, and then again this phenomena goes on. Now if we still reduce it, the whole kind of still more, if you reduce the pressure, the whole tube kind of takes away this Crookes dark space, gets more and more expanded, and this whole thing disappears, and Crookes dark space kind of expands. And around what happened when the spectrum glow is still there, there is a glow around, kind of blue glow around the cathode, and the pink glow around the anode, and there is Crookes dark space, but still there are glows around cathode and anode. The glow around cathode we called it as cathode glow, and glow around pinkish glow around anode we call it as anode glow. But still around 0.01 millimeter of mercury column pressure. At this pressure, most of this area is taken up by this Crookes dark space, and it's mostly dark. At this point of time, when we still try to reduce the pressure, what happens? The whole tube glows up, which a kind of in a very bright glow, and this phenomena we call it as fluorescence. And what happens generally, the opposite wall, this wall, the opposite wall of cathode becomes a very glowy, and this phenomena is called fluorescence. And what happens is, after when this fluorescence things happen, when this phenomena happens, generally this is occurring because there are very high velocity particles that is coming out from cathode, leaving the cathode and coming out, and they are kind of bombarding this this tube, this wall of the tube, and that's how it's becoming glowy. Then this particles that are coming out, those cannot be seen with eyes, but what happens is when you study this, we call this as cathode ray. Cathode ray is made up of particle which then after these studies, scientists like Crookes, Leonard, J.J. Thomson, they have taken up the study of the particles of cathode ray, because this ray is coming out of cathode, and then there is a very mysterious glow that is taking place in the whole discharge tube, and this is what phenomena which we call it as fluorescence. Now, when the different scientists started studying about this cathode ray, it was J.J. Thomson who first, around 1897, what happened, he was the one who found that these particles were actually negatively charged particle which makes the cathode ray. They are negatively charged particle, and the ratio of the charge by mass, the ratio of their charge by mass is around 1.76 into 10 power 11 coulomb per kg. So he was the one who first gave charge to mass ratio. He also told that these particles generally are very highly like high speed charged particle, and they are around 0.1 of the light, that is c, to 0.2 c. Their velocities are such high, 0.1 or 0.2 times of the velocity of light. So this is what the concept that was given, that we have got from this kind of ray that was coming out, and this particular particles are negatively charged. Then around, this was given by J.J. Thomson around 1897. So around the studies were going on, and around 1913 it was Millikan's study. And one more thing, J.J. Thomson has given this negatively charged particle name as electron. So this is the electron which now we know as electrons. This is actually the particle that has come, or that was first seen in cathode ray inside the discharge tube. So around 1913, Millikan was the first person to give the charge of this particle called electron as 1.6 into 10 power minus 19 coulomb. So once we got the charge, then from the J.J. Thomson's E by M ratio, when you put the charge, you will get the mass. And when we got the mass from this, we saw that the mass of this particle is lesser than one atom. Suppose we have an atom, suppose this is in one particular atom, and this electron mass is around 1835 times lesser than an atom's mass. Till then, it was Dalton's theory, atomic theory, which said that atoms cannot be divided. But now here with this experiment of discharge tube, that we are getting a particle which is much lesser of the mass from an atom. So then Thomson and all of them, they declared that atoms can be breakable. Till then, it was Dalton's atomic theory which says that atom is the very small existence, the fundamental particle, and it cannot be divided. But now these experiments prove that there are smaller particles which cannot be seen through eye, which has very high speed or very high velocity, which has very less mass, around 1835 times lesser than a smallest atom, which is the hydrogen atom, suppose. So the smallest size of the atom, least than that, 1835 times lesser of that mass. So there came the concept that this is the ray that is coming out as a radiation, and this ray is actually made up of particle, or made up of the matter, or this is the particle which is the very fundamental particle of the atom. So it means that atom means we say that matters are made up of atom. So the fundamental concept of matter is atom, and now we see these waves or these rays are made up of very fundamental particles called electron, which is made up of more fundamental particles, which is a fundamental part of matter. So here we see at this level the waves are made up of this fundamental particle of matter. So therefore we see the first thing that comes out is the concept of electron, or the charged particle, the fundamental particle of matter, which is making this ray, and then we will come to see that how various other phenomena and how these electrons are ejected, and how the whole thing is going about. And therefore the discharge tube phenomena become very interesting and very important in any discovery, in all further discovery of modern physics.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.